Hi, in this video I want to showcase a static site generator I wrote in Chicken Scheme, and I'll also show how I wrote it, or at least the basic building blocks of it. So first of all, what do we want? We want to generate a website from a markup-like file, so we don't want to write all the HTML by hand, but rather have it generated automatically. And of course with markup there is, for example, Markdown, which I also use here. There's also org mode and stuff, but we're going to use Markdown. And so let's just start by having a few examples. So we can have a section with a hash symbol. We can have normal text, like just write normal text. We can have italics with stars and bold with 2 stars and lists like so, and so on and so forth. And if I take this file and transform it into HTML with my static site generator, then I get something like this. Okay, this looks pretty ugly, of course, but you can see how you can add some CSS like here, and this can be very easily turned into an actual site, but this is just for demonstration purposes. Alright, but what you'll also notice is these angle bracket things. And this is not Markdown, at least not as far as I know, but this is rather some special syntax I added so that everything be in between these angle brackets, in between here and here, so all this stuff gets interpreted as Lisp code or as Chicken Scheme code. So I want to show you how you can write something like this yourself, because it's really pretty simple. Again, for the Markdown stuff we're going to use Pandoc. So Pandoc is just a program, or well, it's a program that converts different formats. So for example, from Markdown to HTML, or from HTML to Markdown. If we call Pandoc, we get, well, it does nothing, it waits for input. And if we input some text and then terminate with Control D, we get the HTML representation of this Markdown. So we can also, of course, do something like this, and we get italic world. Okay, so far so good. Alright, here I have the source file for my converter, so this is all the code, so over 100 lines, but it's pretty dense code and there are lots of details and little hacks, and I don't think it's useful to show this off, especially because it's always a bit annoying to read someone else's code. So this is the entry function. You give it a file name, like this test file here, and it converts it to test.html. Alright, but how can we do something like this, or how can you do something like this yourself? First of all, I want to show how you can pipe something into Pandoc or call Pandoc with a string from Chicken Scheme. I'm using let values here, so okay, let's start from the beginning. Process Pandoc opens the program Pandoc, like we just did here at the command line, so it just does this. Then it gives back input, output, and process ID. Process ID we don't really care about, but output is basically if we write something into here. I mean, normally you'd call it input, like input and output, in my opinion, is here the wrong way around. So I should actually change those, but in the documentation it's this way, so I just kept it that way. So now we want to write something in, like our hello world. We can do this here, hello world, to our output port, or rather input port. Then we're going to close the input. We're going to close the input. We do this here with Control D, and then we're going to read the string that Pandoc outputs, like this string we're going to read. And yeah, that's it. And if we evaluate this code, then we get exactly what we wanted. So here's the code we just evaluated, and here is what it gives us back, and that's this hello world. So exactly this, plus a new line, which is also present here. So yeah, pretty cool. Alright, let's get rid of this. So far so good. We now can convert Markdown to Pandoc, but we want to, of course, evaluate list code within our Markdown document. So far we can like write Markdown and do like Markdown things like italic and bold and so forth. Now let's read in this with input from file. Is it this and then this and then vid? So okay, we have a new file called vid, and we have this content within it, and now we want to read it into a string. So we do it like that. So we get back a string with these contents. If we add something here now, add something, save and reevaluate, we get that in the string also, obviously. Alright, nice. Now we can, of course, pass that into Pandoc, like this, and evaluate that, and we get back this input transformed into Markdown. Okay, so that's pretty cool. But again, that's only Markdown to HTML. We want to evaluate actual code inside of this. How we're gonna do that is we're gonna split the file. Okay, let's first have here some code we want to evaluate. And now we're gonna split the file. So, or the string rather. So we're gonna call a string split on this, and then we're gonna give it our delimiter, which is these angle bracket things. And then we're gonna pretty print that. Yeah. Okay, it doesn't matter. It's not pretty print that. So we get back a list with 3 elements. The first one is our Markdown up to this point, and the second one is the code we want to evaluate, and the third one is the empty string. Because yeah, after this last angle brackets there's an empty string, because string split does it that way. Alright, and now we can evaluate the second argument. How you evaluate code in Scheme is with eval, and then you give it a list, for example this list, and it evaluates it. Okay, great. But now we don't have a list, we have a string, the string representation of a list. If you give that to our eval, so we can get the second element with kadar, however it's pronounced. So we get the string, and if we eval that, we get the string back, because eval evaluates a string, and that's just the string itself. So first we need to read it, so we're going to call read, and since read takes in a port and not a string, we're going to wrap that with what is it, input, let me see, input with, I don't remember, let me search for that, read, open input string, here it is. Alright, open input string, okay, so, and if we call that, we should get our 3, yes, because, again, if we look at this, so we read, that's our +1, 2, and now that is not a string, but rather a list. So if we call list on this, it should evaluate true. Yes. And this list can be fed into eval, which can then evaluate it. Alright, now that all that's left to do is to define a function, eval even, for example, which takes in a list, and then evaluates all the even elements. So the first one shouldn't be evaluated, the second one should be evaluated, and so forth. Yeah, and this is pretty easy now, so we can just return the first element, because we don't need to do anything with that. And then we can wrap this one in another function, eval element, with element e, and delete this, put this there. this, and then we're gonna eval element. So if we evaluate these two functions, and we give eval even a list with two elements, one to not evaluate and the second one to evaluate, it should give back a list with the first one not evaluated and the second one. So we have A and 3. Don't mind the dot. If we wrap this in a list, it will remove the dot. So yes, okay. Yeah, and so now we only have two elements. What if we add some more content, like this for example, and this? We want to, of course, well, first of all, we don't want to evaluate some list like that, but we want to rather evaluate this file. So we're gonna do this, and then we're gonna get back the first two elements, of course, because we only care about the first two elements up until now with our eval even function. And that's this text in front and then the 3. Alright. But of course we have another two elements which are, well, 3 elements rather, which are being ignored right now. So how we can solve this is to recursively call our function. So here we handle the first two elements, and now we want to handle the rest. So we can do another cons here, and then what is it? Here, call this function recursively with cddr. So here we use the first element, here the second element, and then the rest. So everything but the first two elements are being passed recursively to this function, and then we need to define a stop condition, of course, with, for example, some sloppy code like that. So if the length of the list is 0, well, or we can do this. Is 0 or is 1? Yeah, let's do that, I guess. We're gonna return the list, and otherwise we're gonna return, let's do this, we're gonna return this. Yeah, this should maybe work, I hope. So let's test this out. Eval even with the empty list gives us the empty list, with a list with one element gives us one element, and with two elements it should now give us the first element and the second element evaluated. Oh, and we need to remove this list. Exactly, and with 3 elements it should, yeah, it should give the first and the last unevaluated and the one in between evaluated, so this one. Yeah, and you see it works perfectly. Great. Alright. Right, and now we're gonna, so this works. If we use this, then it also works, so we get 1/2 instead of this expression. So this expression evaluates to 1/2, of course. And one thing we need to do is we need to format these as strings, because what we're now going to do is, so now it's a string as you can see, before it wasn't. And what we can now do is we can do string join, and we get one long string with our Lisp code put into the places where there were expressions before. Alright. Okay, and now what we can do is we can feed that to Pandoc. So we're going to define the function, define to Pandoc with an input. We're going to do this, and then we're going to call to Pandoc on this, and you see it gives us back an HTML representation with our markdown and with our Lisp code evaluated. And now we can also display this a little bit nicer. So here we have 1/2, here we have 3, instead of these expressions right here. And of course these are simple examples, like kind of toy examples, but it's very clear that you can do pretty powerful stuff with this, because you can write arbitrary Lisp code in here, which gets evaluated in, within this Markdown file. You can, for example, define custom HTML components like I've done here. Here this is just some header stuff which I've also written, which I don't, we have not, like we don't have a header right now, but it's pretty easy to add a quasi header right here. And now you can, here you can, for example, define a button which gives you back some SXML which can be turned into HTML and so on and so forth, which gives you these very simple buttons, of course, with some basic styling or just, well, red text. But yeah, so I hope it's clear that this can be very powerful, because you can, of course, extend it however you want, and since it's so simple, you can extend it very easily. And so, yeah, it's pretty. I think it's a pretty cool thing. I mean, I've used Hugo, and I still use Hugo, and so on, like stuff like that, and it's fine. It does what it's supposed to do. It's of course fast to set up and it's fast to use because there's so many templates and community stuff and so on. But at a certain point, when you want to do more advanced stuff, I feel tools, like general tools like this, always kind of start to break down. Like you have to do some ugly hacks and stuff like that. And a static site generator is so simple to write, especially with a tool like Pandoc, that yeah, it's really, I think that's the better route to go. Yeah, I'll continue to play with this and maybe build some actual stuff with this, not just idiotic examples like this. And yeah, I hope you learned something, and happy hacking.